Hi everyone, welcome to the A to Z Analytics channel, where I plan to share my knowledge of data analytics and business intelligence through Microsoft Excel and Tableau. I hope you enjoy this video and learn something valuable. If you hit the subscribe button and enable notifications, you will be notified of when new videos are uploaded, which I will be doing on a weekly basis. In my previous video, I gave you an introduction to Excel tables and promised that I would expand on that with a video on table calculations. I'm going to revisit parts of the last video, and then I will look at row level calculations within the table, row level calculations which use information external to the table, and also table level calculations. So what are Excel tables? An Excel table is a range of data that has a specific number of Excel features applied to it. In Excel, a range is an area, i.e. where your data is located. These features enhance the ease of working with that data and can be applied with a couple of clicks. Keep watching if you like working smarter rather than harder. So what value Excel tables add? As I mentioned before, there are many reasons why Excel tables add value, and these included that when using calculated columns, the same formula is applied down the column. If you amend the formula in any cell in that column, the formula in each cell of that column will also be updated. A further feature involves the option to add a total row, although it can be more than just a total row. It can be used to calculate a number of measures for each column, such as sum, average, count, min-max, etc. By default, hidden rows will be excluded from the calculation through the subtotal function, but this can be overridden. I'll quickly talk about name ranges, as they can be important when it comes to understanding table calculations. Ordinarily, when you reference a cell or a range of cells, it is on the basis of the coordinates within the sheet with letters representing columns and numbers representing rows. For example, the table in the top left is A1, as shown in the box here. This represents column A and row 1. The cell below on the next row is A2, representing column A and row 2, and so on. This is how the specific cells are referenced directly. If we wanted to reference both cells, also known as a range, such as the calculation of their total, the formula would be equals sum A1 colon A2. This is all perfectly logical, but not plain English. Having converted this data to a table, a number of name ranges have been created. Firstly, we have already named the entire table Simple Data Table. This is the entire range in which the data sits and one of our possible points of reference. Each of our column headers is a name range, as is the data in those columns. For example, if I type in equals and click on the date header, it shows me the name of that range. Firstly, it sits in the Simple Data Table range. It is a header shown in the square brackets as hash headers, and the name of the header is date, e.g. region or sales value. Clicking on one of the other headers updates that last part of the formula, e.g. region or sales value. If I enter equals sum in the cell and select all the cells in the sales value column, I begin to see the traditional range in the cell and formula bar. Once I have all the values selected, the formula is updated to reference that range. Firstly, it sits in the Simple Data Table and the Sales dollar value column. Closing the formula with a bracket and hitting enter, we will see the total for that column. Applying some smarts to how you name your data will make it easier to understand what ranges are involved in any formulas and references. Next, I'm going to show you the calculated column and some of their features. Looking at the simple data set, we have columns which contain sales in dollar value and costs, and an obvious calculation is profit, i.e. sales revenue less costs. If I select the cell H2, which is to the top right of the table, and type profit, a new column is created. For the data, selecting H3, I'll type in equals and then click in E3 of the sales column and then type the plus symbol. Annoyingly, Excel may cover a cell which you may want to select, such as G3, which makes it difficult to add to the formula. But I do have a good workaround for this. As you can see in the formula bar, when I selected E3, it did not add E3 to the formula, but added the name range in square brackets. At square bracket, range name, close brackets. Knowing this, I can type the name of the range I want into the formula. So if I begin with a closed bracket, some assistance appears. At the top, it suggests using @ for row level calculations, so I type @. And then I have a number of name ranges to choose from. In this case, I can double click the desired and finish with a closed bracket. Now you may notice the sales dollar value is enclosed with square brackets in addition to the brackets around the @ symbol, whereas costs is not. The reason for this is the space in the range name of sales dollar value. This is common to Excel syntax where names with spaces may need to be enclosed with apostrophes or other delimiters in formulas. If I hit enter now, the formula will fill down and calculate the result for each row. As you can see, the profits in Europe are lower than in North America. Another calculated column we could use is sales price per item, i.e. sales dollar value divided by number of sales. And I'll show you another little tip. So I'll select I3 and add the title sales price. Another column is added to my simple dataset table. Now I would type the formula indirectly, equals, square bracket, and the assistance appears. If you look at the top row with the @ symbol, it is highlighted in blue, which means if I hit tab, it will add that to my formula. This removes that option and highlights the date range. So if I press the down arrow until the sales dollar value is highlighted, I can press tab and add that to my formula. I will now add a close bracket and a slash as I want to divide the sales value by the sales volume, and then repeat a similar process of open square bracket, pressing tab for the @ symbol, and then pressing the down arrow until I get to the number of sales, pressing tab, and then closing off the formula with a square bracket. When you see the assistant list appears, you have a number of options, including to ignore it if none of the options are required. But also from the list you can use the mouse to select the range by double clicking its name. In cases where you have lots of name ranges, you can start typing the first few characters of the range name, and the list will reduce to show those with the characters typed. If I press enter, it will calculate the sales price per item. We can see that assuming the same currencies used across the table, that the sales price in both regions is the same. As the profit is lower in Europe, I would assume that costs per item are higher in that region. This is easy to assess in this small data table, but in large data sets you would probably want to leverage the power of pivot tables for your analysis, which I cover in another video. Those were both calculations that use data within the table. Now I'll run through some examples that use data from both inside and outside the table. Assuming they're the same currency, we could create a simple calculation for the tax liability, and I would add a tax liability column to the table. Please note that I'm simplifying the situation, as the tax liability would be a far more complex calculation. What I'm going to do is create a name constant. We can do this by going to the Formula tab and the ribbon and going to Define Name. I'll name the constant tax rate. And set the value to be 0.2, i.e. 20%. Returning to the table, I will go to the first row in my table and will add a formula to calculate the tax liability, which is the profit multiplied by the tax rate, equals bracket at profit close bracket multiply tax. Now we can see that my name constant is available. Now when we press enter, the tax liability will be calculated for each row. We can also do the same using any cell or named range. We could create a reference sheet which had various variables which could be adjusted by the end user. If I add the value 0.1 as my new tax rate, we could amend this formula to reference that cell by deleting out the tax rate name constant and pointing to the cell in this sheet. I'd want to fix the location of the cell which is referenced, so I can press F4 to cycle through the fixing options. I want to fix both rows and columns. Now when I press enter, the tax liability is recalculated for the entire column based on this value in the cell 0.1. If the tax rate was to change, we can simply update this value to 0.2, and once again the table recalculates. Ordinarily I'd like to define this as a named range for readability, so I could call this tax rate B2, as I already had an existing tax rate which references that cell, and click OK. Now I can amend my formula to be that name range, tax rate B2, and we will have the same functionality, but the formula is much more readable. Moving on, I'm going to add a total row. So if any cell in the table is selected, navigate to the Table Tools Design ribbon if it is not currently visible. In the center of the ribbon, in the Table Style Options section, there are a number of different options which can be selected. One of those is Total Row, which I am going to check. An additional row is added, and by default it has added the total for the final column, which I had selected earlier. If we click on that total value, we will see a button appear which looks similar to the filtering button. If we click it, it will reveal with blue highlighting that the default calculation applied is total, which is appropriate for this column. If I have the cell selected and I copy and paste to the sales price column, you'll note that the total is the same result. This is because the formula references the range from which it was copied, which we can see in the formula bar is the tax liability column. We can click directly in the formula bar and replace the reference with the sales price. You may have noticed that the total sales price is not a valid result for most purposes, and what has been calculated is a total of the average sales price across all periods. If we click into the cell and click this drop down button again, we can see that there is the option to display the average, which makes much more sense. I will add some for the other numerical columns. I will do this by selecting the option from the button adjacent to each cell. We can reference these calculations in a calculation within the total row or outside of it. If we look at the total profit, we can see for that column is 3.25 million. If I delete the calculation, I can replace it similarly to the previous row calculations for profit and sales price. I will type equals and select the sales total. If you review the formula bar, it shows the syntax where the table range is firstly referenced, followed by hash totals, comma sales value, and a number of square brackets. As before, I will add an operator, in this case the plus symbol, as I want to add the negative value of costs to the sales total. Once again, the cost total which I want next to select is covered, so I will continue typing. If I type in SIM, we see my simple data table appears. So I'll select that, and then 2 square open brackets. And the assistant shows the total options which I require. And then finally, costs, followed by 2 closed brackets, and when we press enter, the same result is obtained. Previously I calculated the sales value total for this data by adding the sum formula and selecting the range. You can see in the formula bar that it's calculating the sum of the sales value range in the simple data table, which is useful in itself. One key difference between that calculation and the total in the table itself is that the table uses the subtotal function. This recalculates to exclude hidden rows if filtering is applied, which may or may not be desired. If I filter by region to show only North America, you will see that the total in the table reduces to 5 million, whilst the sum remains at 8.75 million. If we select that subtotal, you will see a number alongside that named range, which defines what type of calculation is performed. Deleting the number will reveal an assistance list to help you pick the type of calculation, which we want to leave as 109. If we look at the sales price average, we will see that the number is 101, which is the function number for average. As I mentioned before, the table ranges are dynamic, so we'll expand to exclude additional columns or rows as required. There is a button in the Table Tools design ribbon which can be used to manually resize the table if required. If I add a couple of more rows in for Monday of the following week and replicate the previous day's data, we can see how that works. You should note that the formulas in the calculated columns have been continued by Excel. When I click on Resize Table, you can see that the table range is already expanded. If I was using this as a source of data, I could update the range by going to the Data tab in the ribbon and selecting Refresh All. Thank you all for watching. I hope you've enjoyed this video and learned from it. I'll be grateful if you could hit the like button to give the video a thumbs up, as it really helps spread the word. If you'd like to see more of my videos, please subscribe so you can be notified of when more videos are uploaded. You'll also find more videos if you head over to my channel. If you have any questions, feedback or topics you would like cover, then please leave a comment below and I will respond. I love feedback and learning from others. All the best, Aaron.